Hello, chat. Hello. Let me give you a brief summary. And the thing is that I wanted to create. I wanted to do at least one LeetCode exercise a day. And yes, a day, for all the 365 days of the year. But in the end, I said no, I can't do that because that would take a lot of time. And then I said, well, at least I could do one LeetCode exercise a week. That's more feasible. But this time, the first 2 weeks, I forgot to stream those weeks. So, actually, the first one I didn't forget to do so. But in this case, in the second, but it wasn't working. The stream was cutting, and I don't know why, but my voice wasn't um, audible. So that stream is no longer in YouTube, and I forgot to stream the previous week lead code exercise. And today I'm going to do a simple one since it's already quite late, and I put off this for too long, so I won't do a medium or hard one. So let me select the source of for streaming. Here it is. Nice. I hope you can see. Well, the problem says Roman to integer. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. And here are the symbols and their respective values. For example, 2 is written as II in Roman numeral, and just 2 ones add together 1, 2 is written as XII. Just 2 ones added together. 1, 2 is written as XII. 12 is written as XII, which is simply X plus II. The number 27 is written as XXVII, which is XX plus V plus II. Roman numerals are usually written largest to smallest from left to right. However, the Roman numeral for 4 is not III. Instead, the number 4 is written as IV. Because when 1 is before the 5, we subtract it, making making 4. The same principle applies to the number 9, which is written as IX. There are 6 instances where this subtraction is used. I can be placed before V and X to make 4 and 9. X can be placed before L and C to make 40 and 90. X can be placed before D and 500. And D 500 and M 1000 to make 100 and 900. Given a Roman numeral converted to an integer. So for example, if the input is III, the output should be 3, because II is 3. And if the input is LVII, we should get 58 as an output. And if the input is MCMXCIV, we should get 1994, because M stands for 1000, CM is 100 minus 1000. I think M and C is 100. And XC is 100 minus 10, So we should get 90, and IV is 4. The constraints are that the length of S should be between 1 and 15 characters, and S contains only the characters I, V, X, L, C, D, M. It is guaranteed that S is a valid Roman numeral in the range 1 and 399. Okay, so let's start. So S is the string that will give us an output. So let's see. Need to take this into account. What can we do here? If we should use ifs. That's a that for sure. I can place. Sorry, chat. I'm kind of sleepy, so that's why it's taken me a little bit to get this around. And this is from the previous one. I'm going to hide this. So S. Let's see the test case. Okay, those are the test cases. S is a string, and we should get an integer as an output. I think that let me look the Python documentation on how to use if instance. I mean is instance in Python, because I think this could be it, the function that I could use. I mean, a method. I don't remember. I think it's a method. No, it's a function. The variable, a value you want to check. No, it's only for classes. I mean, no. Python. Uh, Documentation. Strings. Uh, I think we should iterate in this over the string. So for I'm going to write for numeral in S if hmm, I mean I'm going to say index in len and in range. If index -1 is equal to S, I mean no, is equal to I and S, and this should be a string of index is equal to the string v. I mean, wait. In Python, I don't want a library. I want this method. So what and count? Can't I just directly use count without splitting the string? It seems like I can, but this string and count. This is the character count on the string. Okay, I'll copy this. So for the moment, I don't need this. The string is s, and what we are going to count is um, let's call this I. Let's call this B. Let's call this X. Let's call this L. Let's call this, let's say, let's see, let's call this D. I know this might not be a quite efficient code, but that's what I can, what I'm able to come up with for the moment. Equal, equal, and equal. It's S count. What I didn't want to do that. So we need to count number of i's, how many v's there are, how many x's there are, how many l's there are, how many c's, how many d's, and how many m's. I mean M, capital M. And now that we've got this, we need to add them all up. And also, we should create a variables for the cases of subtraction. IV. You'll see what ingenious way I'm going to solve this problem. I know. I think this is a cool way to solve it. You tell it. I think. I think it's cool. Well, chat. While I do this, I'm going to tell you that recently, I mean, like uh, the day before yesterday, I uploaded a new video about on the macaroni constant, and it didn't get as many views as I wanted it to get. But well, I guess I should settle for it. At least I learned a bit. Uh, I didn't actually. I learned about the Bertrand's postulate. I learned about something known as uh, periodic valuations, and that's cool. I learned about in number theory while making that video, so it was worth it. Um, you know, just wanted to comment it, to say it. L XT CD and cm. XL. XC. I didn't mean to. That's it. C D and CM. And what this is going to return is the next. So if we've got um, the total number, we should add them all up. So we should add I mean, yes, just I plus the value of x, I mean of v, is 5. So I need to add 5 times how many numbers we have v, I mean how many times we have v in the string, plus 10, because that's the value of x times the number of times x appears in the string, plus the L is what? 50. So 50 times L plus 100 times number of times 100 appears, plus 500 times the number of times D appears, plus 1000 times the number of times a 1000 appears, or M appears in the string. And from it, we should subtract the number of times. What's the value of IV? That's 4. We should subtract the number of times IV appears, and number of times the value of IX is 9. So minus 9 times the value of number of times 9 appears, minus the number of times XL appears. XL is what? 40 times XL. I mean minus 90 times X C, XC, XL, XC, and now we need to do 400 times CD minus 900 times CM. So I think it's all right. So return, and let's do it. Let's see what we brought. What happened? It doesn't handle the subtractions correctly for some reason. This isn't working. Why isn't it working? Might it be that uh, Excel, XC? In what cases does this would happen? C and D, C and D, C and M, X and L and C, X L X C, I V I X, I V I X, I V I X. Oh, I see, I see. I see the misconception I did. So this is not a good implementation. IV is not worth. Uh, I mean, it's worth a full, but I shouldn't subtract it. I see now. This is 1, this is 1, this is 50 minus x is 10, this is 10 as well. See it? Is this right? I think it is. I hope it's right. This is 1,000. No, this is 500 minus 100. I mean, minus what? This is 50. This is 10. So this is 100. I hope this is it. Let's it again. I think I did wrong again. Yes, I did it pretty bad. That was awful. Let's remove this once. I see, I see. I think that I see. So if we've got an IV, we need to remove one I and one V. That would be counted as 6. What's happening? So, I think I know what to do. Because let's do this. Like, uh, generate 26. We remove one I, and one I is worth 1. So minus 1, and we remove 1 V, which is worth 5. And we add a 4, because IV is worth 4. Minus 1 minus 5 is minus 6, and plus 4 is okay. So this minus 2 times IV. I already understand the logic. And so we need to remove one I and remove one 10 and add a 9, and that's 2 as well. Minus 2 times IX minus. So we need to subtract minus minus 10 minus 50. Yes, I mean 50. The L is 50. And add, we need to add IX, I mean XL is 40. 40. And that is 20. 20 times XL. And the same will happen for XC, for the difference is the same. XC minus those, the pattern is multiples of 10, so I'm going to, of 2. Yes, of 10. It increases by a factor of 10. And CD minus 200 CM. CM. And that's it. Let's try it out. No. Yes, excellent. And it has a runtime of 0, chat. Let's see how well I did. Submit. I beat 81.02%. Why, if the runtime was 0 seconds? How is could it be? Uh, what's this? Oh no, I don't want this. Descriptions, solutions. Let's see the solutions. This guy is just so freaking cool. Let's see how he solved it. Oh, he first makes a dictionary. I can't see. He's doing. He's using the zip function. Now, so what he's doing is A and B, and first he's iterating over S, and at the same time he's iterating over S, and a character. I mean, over S and the next character. Uh, so if Roman of A, this is the dictionary he's using. If Roman and the value associated with A mm, zip. Zip is an iterable, but he's using a what? I don't quite get it. Well, his solution is not that fast. Yeah, I think my he has a runtime of that bit 42.43%. Well, I don't know, but the my intention in seeing this video is to learn, so that's okay. Oh, I see, I see. These aren't numbers, these are the characters in the string. So if the value associated with the with the Roman and A is less than the value associated with Roman and B, and that is the previous the one you're iterating over and the next one, you compare them, you should subtract the residue. I guess that's res stands for residue. And you subtract, and you turn uh, you update the variable residue and turn it into Roman of A, the value subtract from it. And Wait. I then or else the adds it. If it's not less than the next one, it adds okay. And then at the end of the for loop, he will return res. He is going to subtract all the values associated with each character and add all that to Roman of s minus 1. He's going to add it to the last character of the string. Why is he going to add it to the last character of the string? No. Uh, Roman. He's going to take the associated value of the string of the last character of the string because the res already has encoded the previous characters. I think I see why. Well, it's just like a conjecture, but since this iterates up to the last character, uh, since s from 1 to the last character is 1 less than s in length, it won't iterate through the last, over the last uh, character of s. So you need to add the last character. Okay, the last value. So okay, that's kind of cool. But I think I like my solution. I don't know. I think it was pretty cool and more of a mathematician. Where is the code? Why can't I? Okay, no, I don't want it. That's it. Okay. Oh, I think I zoomed out a little bit too much. Com so this is like the top solution. Oh, now I see. Well, memory it's quite bad, this one. Yes, it's pretty bad. Whoa. That this is okay. This is kind of overwhelming as at first glance. For you need to define the methods that it takes. Well, I want to see the solution that takes 0 seconds of runtime. This is weird. No, forget it. But then I don't understand why does it say that it takes 0 milliseconds here, but here in runtime it says it takes 3 milliseconds. That's kind of weird. Let's see the 0 milliseconds runtime case. So he has a dictionary, which is what this guy over here did, and the total, he defines a variable total and sets it sets it equal to 0, and he does a for loop and goes from the first of the one less of the previous character before the last character of the string. And if converter is of s high, so that is the value associated. That's basically what this guy did here. What? How could this? I don't get it. Well, I guess my guess is that in the 0 milliseconds run version, because I already see because the solution this guy gave is quite similar to this one up here. The thing is that this solution didn't use the zip function, and I think that is what made it increase in runtime as opposed to this one. Because look, this just compares I and I plus 1. Okay, nice. This solution is pretty cool actually. But I also liked mine. Look, well, not quite. I mean, as a mathematician, I like it, but as a programmer, I don't like it. Well, I guess I'll get more used to making good code and efficient code. But well, 81.2% is not bad. I think I reckon that's nice. Well, chat. See you next time. Bye. Good night. Good night. Night.